Hello, we are actually, I am actually going to explain problems 1 and 3 for group project 1. Problem 1 says find the exact area enclosed by the inner loop of the curve r equals 1 plus 2 sine theta. Now, the first thing we're going to do here is actually find the limits of integration. So when r equals 0, what are the limits of integration? So we have 0 equals 1 plus 2 sine theta. Sorry if that's a little blurry. So what we're going to do here is we're going to solve for theta. So we're going to minus 1 from both sides, and we get negative 1, and then equals 2 sine theta. And then here we're going to divide by 2. So we have negative 1 over 2 equals sine theta. And theta equals 7 pi over 6 and 11 pi over 6. So right here we can tell 11 pi over 6 is actually going to be the upper limit. And 7 pi over 6 is actually going to be the lower limit. So our second step is we have to plug these into our area formula for our inner loop. So we have a equals b, the upper limit, and a, the lower limit, 1/2 r squared d theta. Now a equals, and then we put in 7 pi over 6 for theta for the lower, for a, I mean not theta, sorry about that, for the lower limit of integration, and 11 pi over 6 for the upper limit of integration. So we have 1/2 plus and r is 1 plus 2 sine theta, which was the original equation, squared d theta. And then we're going to FOIL this actually. So we're going to have 1/2 1 plus 4 sine squared theta plus 4 sine theta d theta. And now there's a half angle identity. So we have sine squared theta equals 1 minus cosine 2 theta over 2. And actually, we're going to take the sine squared theta right here, and we're going to replace that with 1 over cosine 2 theta over 2 plus 4 sine theta d theta. So then we get 1/2 times 1 plus 2, 1 times cosine 2 theta. And we got this 2 from here where the 4 divided by 2 is actually just 2. So we got 2 times 1 minus cosine 2 theta plus 4 sine theta d theta. And then we're going to multiply this. So I got 1/2, 1 plus 2 minus 2 cosine 2 theta plus 4 sine theta d theta. And then we're going to continue from this here. I'll scroll up a little. We're going to continue. So we have 1/2, and then we're just going to add this 2 and 1. So we're going to have 3 minus 2 cosine 2 theta plus 4 sine theta d theta. And the third step is we're actually going to take the antiderivative and plug the limits of integration. So we have the antiderivative of this equation up here. So we have 1/2 3 theta minus sine 2 theta minus 4 cosine theta. So we're going to actually just plug these in. So we have 1/2 3 11 pi over 6 minus, sorry if that's extremely blurry to see, minus sine 2 11 pi over 6 minus 4 cosine 11 pi over 6 minus 1/2 3 7 pi over 6 minus sine 2 7 pi over 6 minus 4 cosine 7 pi over 6. And then we're actually going to simplify this a little more. So 3 over 6 is actually just 1 over 2. So we got 11 pi over 2, and then 11 pi over 3, because 2 over 6 is 1/3. And then we got 11 pi over 6 here, and 3 over 6 is just 1/2. So we got 21 over 6, pardon, that's my bad, minus sine 2, 7 pi over 6, minus 4 cosine 7 pi over 6. And then we are going to really kind of simplify this even more. So we get 1/2 equals 11 pi over 2 plus sine pi over 3 minus 4 cosine pi over 6, and then minus 1/2 bracket 21 pi over 6 minus sine pi over 3 minus 4 cosine pi over 6. And then we actually get 11 pi over 4 minus 7 pi over 4. And right here you can see a common denominator. So then we're going to add sine pi over 3 minus 4 cosine pi over 6. And we get 4 pi over 4 plus, and then sine pi over 3 is actually just square root of 3 over 2 minus 4. And then cosine pi over 6 is just square root of 3 over 2. And then we get pi plus square root of 3 over 2 minus 2 over 3. And then right here, as we can see, this doesn't have, we don't have a common denominator here in order to subtract. So we're going to multiply by 2, so it's going to become negative 2 times 2, which is negative 4 square root of 3 minus 2. And essentially, this is 1 square root of 3 over 2 minus 4 square root of 3 over 2. So we get pi equals negative or pi minus 3 root 3 over 2. And that is our area enclosed by the inner loop of the curve r equals 1 plus 2 sine theta. Now, if we go to problem 3, so as you can see the graph right here, so this is r equals 3 sine theta, and this equals r cosine theta. And right here is actually the area where we're trying to find for the exact region between these curves. Yeah. Now, problem 3 states, graph the polar curves r equals 3 sine theta and r equals 3 cosine theta, as I showed above, on the same set of axes, and find the exact area of the region that lies inside both of these curves. So we're going to set these equal to each other. So we're going to get 3 cosine theta equals 3 sine theta. Cosine theta, and then we're going to divide by 3, sorry. And then it's cosine theta equals sine theta. And we're going to divide by actually, I'll show you in a bit. So we get 1 minus sine theta over cosine theta, which is actually a trig identity, which is tangent theta. So we get tangent theta equals 1. So what does theta equal? And we got theta equals pi over 4. Now, step 2 we're going to do is actually just plug this in to the previous equation we used for problem 1. So it's just a to b and then 1/2 r squared d theta. And we have two equations actually, and we need to find the area between these two curves of the graphs. So we got pi over 4 here for one of the limits of integration. So for the 3 sine theta, we can actually see that it goes from 0 to pi over 4 for the limits of integration, or between these two curves. So if we scroll back down, we can see the limits are 0 to pi over 4, and it's 1/2. We just carried out the 1/2 here, and then plugged in r, which is 3 sine theta squared d theta. And then we did the same thing here. So this time we're going from pi over 4 to pi over 2, and then it's 3 cosine theta squared d theta. And so to find the area of this curve, it's actually split in half, as I showed in the graph above. So all we have to do is take one of these integrals, and whatever the answer is to that, we just multiply it by 2 simply. So we have this 1/2 here, and we multiply the 3 sine theta squared, so we get 9 sine squared d theta plus 1/2 pi over 4 to pi over 2, 9 cosine squared theta d theta. So since we're going to use one equation, I'm actually going to use this one right here, the one with sine, because I feel like that's easier to evaluate, especially because there's a 0, and you're not going to simply have to do much with that. So since we're timesing it by 2, it's just going to be right here, 1 over 2. We could just simply times that by 2, so it's just canceling out. And then we move this 9 over, and then we have 0 to pi over 4. And then a side note here is that sine squared theta actually equals 1 minus cosine 2 theta over 2. So we're going to plug that right here, and then we have d theta. And so we're just simply going to take that antiderivative and evaluate this. So we have, I'm going to take this 2 from the denominator and just pull it out actually, because we could just have 1 on the outside of the parentheses, so it would be 1 over 2. So we're just going to carry that out. So it's going to equal 9 halves, and then times, and then these antiderivative of 1 is just theta, and then the antiderivative of negative cosine 2 theta is negative 1/2 sine 2 theta, and then from 0 to pi over 4. So we're simply just going to plug in pi over 4, so we get 9/2 times pi over 4 minus 1/2 sine 2 pi over 4. And then this one right here, we could just cancel out. This is just going to be 0. So we're going to multiply this, and then we get 9 over 2 times pi over 4 minus 1 over 2. And we get 9 pi minus 18 over 8. So yeah, those are the two problems.